Pole discrepancy relay. In ANSI code, it is expressed as 52D. In 220 kV and higher system voltage, three-phase circuit breaker used are separate operated pole type. That is, in presence of fault in a feeder for a particular phase, the fault sends by the distance relay of the said feeder and initiate a single phase tripping command only for that phase in order to clear the fault. And also auto reclose command is initiated after dead time of around 600 millisecond to 1 second and reclose that phase of the circuit breaker. Therefore, in 220 kV or higher system voltage or where three separate pole of circuit breaker are used, pole discrepancy relay is used in the circuit breaker end in order to ensure closing or of the circuit breaker pole or opening of all the three pole within a predefined time duration. Basically, pole discrepancy feature is incorporated through a timer and fixed time is set in that timer after which pole discrepancy is supposed to initiate. Normally the timer time is set at 1.3 to 2 seconds in the pole discrepancy timer. Then if there is a mismatch of more than 2 seconds in the breaker opening or closing time, then pole discrepancy shall operate and shall trip all the three pole of the circuit breaker. Why use pole discrepancy relay? Pole discrepancy relay or protection is used to protect the generator or alternator from single phasing when the circuit breaker is failed to auto reclose or reclose all the pole at the same time. Pole discrepancy protection is little bit different from the LBB protection. When the LBB protection operate, when the circuit breaker failed to operate all the three pole, that is failed to trip the three pole simultaneously, the relay trips the upstream breaker, that is the all the breaker associated with the bus, and also send the trip signal to the far end of the said feeder. But in case PD protection trips the same breaker during a predefined time, it may be due to circuit breaker internal mechanism failure. Hence, the breaker pole will be closed unequally or delayed. How the logic is done in pole discrepancy relay is shown in this diagram. In this diagram, for example, if a feeder sends a R phase transient fault, it is sensed by 21 relay, that is distance relay, and initiate a R phase tripping by means of 86R and TC1 of R phase of the set circuit breaker. Therefore, circuit breaker R phase pole tripped. As soon as the circuit breaker R phase trip, pole discrepancy relay timer started. At the same time, after dead time of 1 second, auto reclose command from 21 relay has been initiated in order to close the R phase of the circuit breaker. R phase pole of the circuit breaker closed. If there is a mechanical problem, it will not close. Therefore, the pole discrepancy timer initiate to trip all the three poles after the predefined time as set by 1.2 to 2 seconds. If the R phase pole is closed, then feeder is in normal condition, then it said the timer of the pole discrepancy relay automatic reset. Consequences: pole discrepancy causes unsymmetrically current in the power system, negative sequence current that will give stress on motor and other electrical loads, unnecessary or nuisance tripping of standby earth fault relay due to flow of zero sequence current in the power system. A pole discrepancy circuit has been shown in this figure. In this figure, A5 is the pole discrepancy relay. It has a inbuilt timer by which we can set the timing of the timer from 1.2 to 2 second or as required. Here S0 and S1 are the auxiliary NC and NO contact in unenergized condition of the circuit breaker. Here three separate pole of the circuit breaker contacts are being shown. FS1 and FS2 are the fuse. The trip circuit of the pole discrepancy relay has been shown in this figure. In this figure, RTR, RTY, RTB are the remote trip from R phase, Y phase, B phase respectively, and PTR, PTY, PTB are the protection trip for R, Y, B phase respectively. Here the separate trip coil are used for R phase, B phase and Y phase. Here only the trip circuit 1 has been shown in this figure. Actually there are two separate trip coil for each circuit breaker pole. Only one trip coil circuit has been shown in this figure. A3 and A4 are the contactor for SF6 lockout. If gas pressure of the breaker is under normal condition, then A3 remain in closed condition. A6 is the contactor for trip 1 and 62X is the contactor for PD multiplier. The diagram for A5, that is pole discrepancy timer, and 62X has been shown in this figure. In this figure, contactor for 62X has been shown 1, 2, 3, 4 and 5, 6. As soon as A5 energized after certain time, the contactor 1 and 2 and 3 and 4 and 5 and 6 will closed. As the contactor 1 and 2 close, 62X will energized. As soon as 62X energized, it will send the trip of the R phase TC1, trip Y phase TC1, trip B phase TC1 by closing the contact 1, 2, 3, 4 and 5, 6 respectively. They are used another contactor 62X1 that is used for pole discrepancy multiplier for TC2 circuit that has not been shown in this video. Now under normal condition, that is all the circuit breaker poles are closed, the diagram shown in this figure, there is no possibility for A5 relay to energize. Again, if all the poles of the circuit breaker are open, there is also no possibilities for A5 or PD relay to energize. Now, as the R phase breaker pole is open but Y and B phase breaker is closed, the A5 relay will energized as shown in this diagram by red dotted line. Now if R phase breaker is open, as the A5 relay is energized, now the other trip circuit, that is TC1 of Y and B phase, will be energized as shown in this diagram. How the TC1 of Y and B phase energized as shown by red dotted line. Friends, if you like my video, please go through my channel and please share my videos between your friends, and please comment for any query, and please subscribe. Thank you very much for watching my videos. Thank you.